So why abstraction? Why does abstraction exist? Why do we need it? Why is it required for the derivation of computational solutions? Because we need to take a lot of stuff and somehow organize it and represent it. Databases, for example, a phone book, a phone book is a database. So you wouldn't have a phone book just be a bunch of phone numbers randomly scattered on the floor and a bunch of names, that were associated with those phone numbers equally scattered around. You'd have structure. And that's what computer science is. Computer science is basically the study of complex systems and the management of them. And so we are managing very complex systems. That's why we need abstraction. That's why we need to think of an order to give all that information and a way to organize it. And we will be focusing in on object-oriented programming. And do I want to give you a brief intro? I guess so. I guess that's where this talk is heading. So here we go. Your first ordered Java, I'll just call it my first OOP class. And what shall it be? Well, it should be something specific, so let's actually call it what it's going to be, and I haven't thought of that yet. Java class. It's going to be sheep. I look up in the room I am right now and I see a stuffed sheep, so that's what it's going to be. Sheep. There we go. So sheep. Now what would a sheep have as attributes and as methods? Because the idea is that we're going to take something complex and break it down into something more straightforward. Well, sheep, again, I'm thinking off the top of my head, but is the sheep, well, how about the color? So color would be a string. And you'll get how this works shortly. And what else? Is it real or is it a stuffed sheep like I'm looking at? That doesn't make sense. So let's say there's a sheep on a farm. Is it for shearing or is it for something else? So Boolean is for wool. That's the purpose of having the sheep on the farm. We'll start this as being false. And what other thing? How about an int? We'll go int age of the sheep. Why not? Starts at, I'm going to put mine as 999. You're going to see why in a moment. Basically, what we can do then is we can make multiple sheep. Our sheep constructor, one of them's not going to do anything, and the other is going to take in a string color and a Boolean is for wool and whoops and int age. And what that's going to do when we make a new sheep is it's going to go this dot color assign color. I'll explain all this in the next few minutes. This dot is for wool. This assign is for wool. And this dot age is assign age. Okay. So the idea in terms of abstraction is that now we have on a farm, okay, let's say that we're a farmer of sheep and cows and whatever else. We have the ability to keep track of sheep. And in fact, why don't I just do a copy and paste here and do a cow. Okay, so maybe a new class called cow. It's not going to have the same attributes and methods as the sheep, but it could have color? Probably not. What would be something about a cow? Don't know. Boolean is dairy versus this from a person who's becoming vegetarian. But anyway, age, sure, we'll leave age, and we'll change this to cow. Whoops. I'm not going to change that much because I don't want to make this too long. This is just a, much more on this later on. Okay, color. There's going to be colors of the cow. We'll just leave it like that. So if we had another main method, main class, main farm class, in that we had a main method. We could make a database, as it were, of our sheep and our cows. We would go sheep S1 is assign new sheep. And what is that sheep? Let's go take a look. The sheep, yeah, it's going to have black, true, boar. I don't know how old sheep get. Black. I'm not sure the black are used for wool, so let's say white, true, 4. And I'm going to do a couple more sheep and a few cows. And as I do this, I mean, just me going through this is showing you how something initially quite simple is getting increasingly complex. That's 2, 3. And again, that's just the whole point. So let's say C1, C2, and C3. That's the whole point of abstraction, is things get, what we got is dairy. So let me do the cows. White, I don't know, white and brown, false. Dairies are the white and black, so let's go white and black. True, 6. 2, just a brown, false. Maybe. Nah, false. So all these ummings and ahhings and thinking and whatever is just showing you how even now with something that was just an idea a couple of minutes ago is now getting a little bit complex. But this is a way to manage what all sheep are, to make sure that they all have 3 pieces of information with them and they are built uniformly. Whereas the cow instances, or cow objects, are built slightly differently. And actually, why don't we make it even more different? Say that the cow actually has 4 attributes. Color is dairy, age, and let's do a float. Just put in a float. Float, what would have a real number? Real number could be its weight. So, weight starts at -999. And putting -999 without going into a lot of details here, because I want to know if things don't get set. If I have a cow weight that comes up as being 999, I know that, oh, we had a problem. We didn't actually set it correctly. So let's put this in as well. And this dot weight, which is the weight, it's that one, is assigned the weight here. We haven't even gotten into all this, but so back to the assessment statement without jumping ahead by months and months and months. Abstraction is required when we're dealing with complex situations. For us, the complex situations we'll be dealing with in an object-oriented programming way. And we will have classes. Right now, we've got 3 that we're using, the sheep class and the cow class and the main class, which uses both of those. Oh, and now, one last little bit of object-oriented programming. There is no constructor for a cow, which only takes 1, 2, 3. We changed it to taking in 1, 2, 3, 4 pieces of information. So, oh, wait, kilograms, oh, geez, I don't know, 300, the 400, and 500, I don't know, that's a big cow. Complex situation, a farm with different animals being represented by objects via this object-oriented programming approach. Complexity given order, in this case through OOP, object-oriented programming, a means of abstraction.